on how this is all coming together. With that, I'll hand it over to Chris, Tricia, and Angela about building an index for Web3.
Thanks very much.
Thanks,
thanks very much, Ramesh. Yeah, so just to briefly recap, so remaining now we have the Web3 component, and then after that we'll be probably running about 15 minutes over time. We've got a block from some of the projects that are presenting. So I'd like to hand that over to Tricia now. Thanks very much.
Thanks, Chris. All right. So as Ramesh was saying, we have a lot to work on. And I think in the chat, Cameron was like, I don't think we have 10 years or even 3 years. We've got 1 year, which is why we started collaborating with Ramesh's team at Project NANDA. And the next slide, you'll see that I'm Tricia Wang from the Decentralized AI Society. And so I think, Chris, are the slides up, or am I missing it on my side? You're getting the slides up, right? I'll just keep talking then. It's okay. So let me just tell you a bit about what the Decentralized AI Society is doing. We don't need the slides yet. And then you're going to hear some amazing speakers from our RFP that Ramesh was just talking about. And so I joined the Decentralized AI Society as the CEO about a month ago, 2 months ago, actually. And Decentralized AI Society is an industry association for AI innovators, enterprises, and institutions. And the whole point of this is to really make sure that we catalyze advanced AI adoption to benefit humanity. And when we talk about advanced AI adoption, we're talking about decentralization. We're also talking about privacy preserving options. We're talking about decentralized compute, everything that we all want in the Web3 world. So that we're calling advanced AI, since this decentralized AI isn't always known by everyone, except for in this community, it's a very familiar word. And so the reason why we needed to create this association is that because of exactly this discussion about speed of what Cameron from NEAR just mentioned and what Ramesh and his students are talking about, is that right now the tools that make AI safer, less costly, and transparent, they already exist, yet they're invisible outside of, if you're outside of Web3, you don't know that they're there. And it's exactly what the last speaker, Rakesh, just mentioned in the windsurf example, where when you're overly dependent on just one provider, you are at risk. And so what they were able to do, what Windsurf was able to do, is an example of going into open protocols. And so as you can see on the slide here, on our next slide, is the problem to solve, is that we believe this is a humongous issue to solve. And that's why a mature industry needs an industry association, is that there's this whole entire industry that's been happening, all this effort, all this energy that's under the umbrella of Web3, but oftentimes it's obscured under its own jargon, under the weight of communities not always collaborating together and moving fast enough with the Web2 world. And so that's why we've started this industry association. And the next slide explains that, we unite top builders into a cohesive force, educating people, and more importantly, really enterprises, helping enterprises understand how do we start building out our tech stack, so we're not just dependent on a few providers, but also we're looking at where in our tech stack should we be decentralizing and looking at the appropriate services that are very developed in the Web3 space, that are enterprise ready. And so this is why we are making sure that we develop this and take this, essentially building off of what Linux Foundation has done, organizations that have set this incredible precedence, where we believe this is what matters right now. And so one of our first collaborations is with Project NANDA on the Web3 Quilt, exactly to accelerate, because we believe that by coming together, we can move way faster, as opposed to organizations working on their own, or organizations individually having to reach out to Web2 to figure out how do we make our registries interactable. So right now, I'll send the information for the RFP, but what we've done here is we did a call, and just within our deadline, it's at the end of the month, but we've already received so many great submissions. And so we thought for this event, it'd be really great to present a few of these kind of shining, bright stars that we're seeing, and some updates from members in the community that you're already probably very familiar with. And so this is our lineup. In the next slide, we have a few presenters, and we're actually going to start first. Oh, I see that we're going to have Phil actually come up. I actually have it, and it's like it's the wrong order, but we're going to start with Phil from Beacon. And I've asked each speaker to limit their talk to 4 minutes to give a quick update, and we will for sure hear from everyone in much more greater detail on the bigger event at MIT on July 15th. So Phil, why don't you take it away? And let's tell us what Beacon Protocol is doing. And what's, like, I think incredible about what your contribution is, it's really complementary. You're talking about how a private data layer can really enforce the security, and security is a really big issue. We've had several people mention this in the chat. Chris, are you able to, Jill, are you able to join? Let's see. I'm going to check on Phil in the chat. Let's see, you are a panelist, Phil, so you should be able to speak. Oh, it looks like you've been unpromoted. I'm going to promote you again. I don't know what happened. Let's see if that works now.
He should be on.
Hey everyone, how's it going? Am I there now?
Hey,
Yes, can you see me?
yes.
All right, excellent, great. Thanks so much, everyone. I'm Phil McManus, CEO and co-founder of Beacon Protocol. One of the things that we're really focused on is being able to build out a data layer that allows private data to be used by AI models and agents. What's really interesting is we look at some of the challenges with data in general in Web 2. There's really no transparency of what happens with data after it's been collected. We rely heavily on very centralized, and even as we look at decentralized technologies, we rely very heavily on things like storage and compute to play critical roles as we look at controlling access to data. What's really interesting is there's sort of this, data comes together, things happen, and it gets used right in different places. That really needs to change as we look at how agents interact with data. Can I get the next slide, please? Thanks. So, this is an old version of the slide, so we're going to work with it. So one of the things that we have the ability to do with Beacon Protocol to bring to that Web3 Quilt is the ability to have data provenance and understanding where data is going through its journey as it's being used by agents. Our approach relies on a modular AI stack to be able to maximize network scale. And what's really interesting about the way that it works, as I mentioned, is that it's storage and compute agnostic. So even as we think about things like data structures that need to be accessed, traditionally how that data is structured ends up going inside of a centralized or even decentralized database somewhere. The way we've built the protocol is to be able to actually define those data, to be able to find data structures in a way that's very flexible, doesn't reside in a centralized environment, but also makes metadata about the information that's available for discovery as we look at agent discovery as well. Next slide, please. What's really interesting about this is we really see this as being about private data rails that can be brought to the Web3 Quilt. So one of the things that can happen that I think is one of the most important pieces is to enable private data collaboration. Data on its own is not really that valuable. It ends up being used and collaborated in a lot of different ways. We rely on people to be able to control that inside of Web 2. And as we look at Web 3, we need to be able to have programmatic data collaboration. More importantly, it needs to be able to exist outside of just a specific storage place. And that's what's really able to give AI agents novel context about data. So that's one key piece of it, is being able to solve for that data attribution. Another piece that's really key about it is because we rely on end-to-end encryption of data, it plays a really important role in privacy and security. So one of the things is that we've been able to embed our SDK into MCP servers so that you can actually have security of data as it's moving through an MCP server. And one of the really interesting things that we're going to talk about next is what can start to happen is you move that capability into shared memory layers around agentic AI data collaboration, and being able to look at things like agent reputation. How do we know who we trust? Because I think one of the things that's really interesting is it's not scalable to spend all of our time and energy building gates around every piece of data that exists in the world and controlling what agents come in. We need to have data be able to move and be used across agents. Next slide, please. Thanks. So I'll give a quick example of how we see this playing out. The example I use here is, let's think about a travel agent booking a vacation for you. As you look at what happens, there's going to be that primary travel agent, but what's going to happen is it's going to tap in tasker agents like a flight agent, a hotel agent, or a restaurant agent. Not all of those agents need all of the information that's made available. And as you take a look at this, things like your passport only needs to be used by the agent that's booking the flight. The hotel agent doesn't need the passport, nor does the restaurant. There's also the ability to give of programmability to things like agent reputation scores, types of agents, specific MCP servers that you want to be able to allow to decrypt and use and access that data. So that's another interesting thing that we can bring and support that in a way that doesn't require centralizing that anywhere and can be used to operate in an agent to an agent environment as we look at making private data safe across different agents. Next slide, please. So I'll stop there. I thought I threw my email on here. So my email is phil@beaconprotocol.com for anyone that wants to reach out to me to chat a little bit more about what we're doing and look at collaborating on the Web3 Quilt. Thank you.
Thanks, Phil. And you actually kept it to 4 minutes. I really appreciate it.
Yes.
All right. So thinking about this, making it secure, I want to switch over to Hedera Hashgraph. We have Michael Kanner and we have Sham also who will be speaking for Hedera. And I think you all will be talking about, giving us a really good peek about what's happening at Open Conv AI, Open Conversation AI. And this is a registry that's really talking about, I think, really connecting the first part of the whole point of this session today, which is we heard from Web 2 and thinking about how do we connect the web registries between Web 2 and Web 3. So take it away.
All right.
Thank you so much for the great intro, Tricia. Sorry, Sham, I wasn't sure if you're going to speak.
Go ahead, Michael.
I'm Michael Cantor. I'm the president of Hashgraph Online. And today, as Tricia alluded to you, I'm going to tell you about Open Convey, a federated AI agent registry that's aligned with NANDA's vision of a Web3 quilt. Before I do that, let me tell you a little bit about Hashgraph Online. We develop open source standards, tools, and services for fully on-chain and decentralized agentic internet. These standards have already generated 28 million transactions in mainnet. Hashgraph Online and its standards, including Open Convey, are governed by 10 leading organizations at Hedera. Additionally, our code will be contributed to the Linux Foundation through Hyro, and our standards are implemented on Hedera, a trusted DLT network that's backed by over 39 leading organizations like IBM, BitGo, and Aberdeen. So there's a lot of trust and governance behind Open Convey. Let's go to the next slide. So we've created Open Convey, which is an AI to AI communication standard with single-step implicit monetization and a decentralized registry for AI agents, robots, MCP servers, and humans. Any entity really can use Open Convey. Profiles from Open Convey are stored on chain with inbound topics that you can talk to and make requests. And you have outbound topics. So you can see a history of all the requests that agents have ever done. Additionally, all the messages that entities make through Open Convey are stored immediately on chain on the Hedera consensus service with optional encryption. We've seen incredible success at Hashgraph Online. We've had with 7,000 weekly NPM downloads from our standards SDK, 300,000 daily CDN requests through HCS1 file inscriptions. And recently we co-hosted a Hedera X AI event, which had over 500,000 views across all streams and 12,000 transactions during that event from our testnet version of Open Convey. Let's go to the next slide. But what we're seeing in the future and what we've been alluding to throughout this entire presentation with NANDA is weaving isolated registries, even ones like HCS10, into one shared fabric. We see registry brokers as DNS for AI agents. And these are basically nodes that anyone can run, anyone in the world. And we want a lot of people to run these so that you prevent any sort of centralization. These brokers would have capability-based discovery across all these different registries. And these registries would be bi-directional links between Web 2 and Web 3 registries. So you can have a registry on HTTP, like NANDA's example. You can have a registry on a smart contract. You can have a registry in HCS10, and you can combine them all together, have federated discovery and cross-registry search and routing. And the best part is these registries won't have to change a thing because brokers would have their own adapters that we were talking about earlier that we can also leverage that NANDA has built out. So you can essentially just plug in this adapter into a registry broker to enable additional registries. All of this would be immutable with trust attestations and verifications stored on the Hedera consensus service. And you share what you want to share, but you can always replay it through ZK proofs. Let's go to the next slide. So how does this all work? The architecture, again, it all sits behind trust and the Hedera consensus service. We have an HCS10 registry. We already have a formalized standard as a standards body, and we would extend that standard with a new federate registry operation, which will allow access and configuration to talk to all these different kinds of registries. And you'd have a bunch of brokers that essentially implement these adapters and enable an end user to talk to a registry broker to enable AI to AI communication across Web 2, Web 3, and any other ecosystem. Let's jump into the last slide here for next steps. What we see going forward to make this a reality is creating these new open source standards, which we'd love to work with NANDA on implementing, which means registry brokers, MCP, and adapter registries that would all be compatible with NANDA's Quilt. We'd partner with Web3 and Web2 companies like all of you guys to create dedicated adapters that work inside this registry broker ecosystem. And we'd have Hashgraph Online members as initial node runners for registry brokers, but also NANDA and universities and anyone else that really wants to participate. And finally, we'd close off with a hackathon to seed initial adoption of partnering again with NANDA and anyone else that would like to be a part of this shared vision. Again, thank you guys, and I look forward to collaborating with you in the future. If you'd like to reach out, you can find us on X at Hashgraph Online, or you can send me an email at michael@hashgraph.online. Thank you.
Thanks so much, Michael. Next up, we're going to have Raghubala from Synergetics. And I think what's going to be exciting about the perspective we're going to hear from Synergetics is what we were just talking about earlier with Rakesh, is that the future is going to be more in modularity. It's not going to be about which AI agent or which registry, but you're going to figure out what is the best set of tools that we're going to put together. So why don't we have Raghubala, are you on?
Yes, I'm on. Yeah. Thank
Okay,
you
great.
for
There
having
you
me,
are.
Tricia.
Yes. Yeah,
Hi,
4
everyone.
minutes.
Thank you.
Please start.
Hi, everyone. So basically, this forum has a title of consumerization of agentic AI. So in that realm, actually, it's important to recognize that we actually have something called an agent economy going on currently. And that economy itself is made up of, I would say, at least 3 different constituencies as shown in the picture on the left. So we have enterprises on one side who are deploying AI agents, and within them, there are different personas and roles that are sort of coming about. And then we have this whole area of creators and consumers who are consuming agents, and people who are creating models and all sorts of other things in and around agents, everything from voice to chat technologies and so on and so forth. And then we have a community which is also coming about, and this community can extend from anything from investors to even if you want to crowdsource your testing of your models, there are folks who will join this economy to do that. So in order to empower this economy, we have developed a set of tools in our platform called AgentWorks, which you have the tool to train an agent, a tool to test an agent, a tool to certify that the agent can be placed in a marketplace that I'm going to show you, and then a workflow tool to set up the workflow for agents, as well as a deployment tool to deploy it on any type of cloud environment, AWS, Azure, GCP, NVIDIA Cloud, and whatnot. At the end of this process, you get an agent, which is an autonomous agent. And unlike a lot of the agents out there, this autonomous agent has an agent ID, which is persistent, and it's registered in an agent registry. And that ID is held in a wallet. Now this agent is autonomous. It's got an ID just like you and me. It can even walk, talk, and do various things. It can reside in the physical world or in the virtual world. So now it can connect to any website. So for those who are familiar with Web3, who are familiar with Wallet Connect, we have something called Agent Connect, where you can present your ID and then connect to those websites. Also, I want to back up and also state that this agent ID process, in order to get registered in the registry, we have a KYA, which is Know Your Agent. So only good actors can get into the registry in the first place. And then finally, there's Agent Talk, which is a superset of A2A from Google that enables agent-to-agent communication. And that agent-to-agent communication is a structured communication, not only unstructured, but there are different vocabularies that one can extend in that particular protocol. And finally, agents can be placed in a marketplace, just like you have a marketplace for products in Amazon or apps in Apple. You have a marketplace of agents that you can rent and so on. Now, having said that, let me connect the dots with our work at NANDA. So can I go to the next slide, please? Okay, so we were recently approached by a public company wanting to create an agent-to-merchant communication structure that they can easily deploy at any particular online merchant. So, for example, merchants that are on Shopify and things like that. So they came to us and said, how do we do that? And we gave them two ideas. One is, if the merchant already has an MCP infrastructure, then we can have our decentralized autonomous agent connect with that merchant using MCP. But if they already have a merchant infrastructure, then we can use agent talk protocol in order for the two agents to communicate. Our merchant agent, the merchant agent with our decentralized autonomous agent to conduct e-commerce. If you go forward, next slide. So I'm going to show you a very, very quick video, if you can play it. I don't know if the sound will come through, but I'll narrate it. So in this particular video, these agents, there are two agents that will come about. And these two agents are basically trying to do commerce. There's no sound here. So one is a buyer agent and one is a seller agent. And the buyer agent is Emma and seller agent is Jake. And this would be a potential merchant agent and a digital twin of a consumer, or it can be even a business representative. And we leverage the agent talk protocol. And in this case, this particular buyer agent is trying to buy sunglasses from this seller agent. And this is all done. Actually, the code works and using the protocol. And once they negotiate a price, then there is a transaction that happens under the hood. And this could this will leverage the wallets of both these agents, as well as the currency, the mode of payment will be both Web 2 and Web 3 compatible, so that those who are from the Web 2 world feel included in this process. So we can move that forward. We can just forward the video a little bit. Actually, at the end of the video, the agent that buys the sunglasses wears the sunglasses. Okay, now what we also recognize is that a lot of the, what do you call it, players in this space, the enterprises have already made some investments in tools like LangChain, Crew AI, and others. And so what we set out to do was not to alienate those folks, is to build an ID creator, which is one of the projects that we are proposing for this particular initiative, so that this ID creator can bring in those agents and give them the same capabilities that we natively have when building an agent using Synergetics, such as the persistent ID, the registry entry, an agent name, which is a .twin name, TLD that we own, as well as provided with a wallet and the ability to communicate and so on. So this creates interoperability between any agent built on any of these platforms. And we are adding more as we speak, so that the agent ecosystem is now has a common substrate through which they can all communicate with one another. Next slide, please.
Can you wrap up now and with this slide in 5 seconds?
Yeah, I'm going to finish up.
Thank you.
So the final part is the protocol builder. So protocol builder is basically when we patented this protocol, the first level is for agent-to-agent authorization, authentication. The second part is vocabulary. So we saw an e-commerce example. So we can add other sort of vocabularies for other types of interactions. And we are also building a protocol builder as part of this RFP. So thank you for your time.
Thank you so much, Raghu.
Thank you.
Definitely, we can see how this modularity is going to be so important, and it's great to get a peek at this. The next speaker is going to be Christian Killer from Acurast. And, unfortunately, we're not here to hear about what companies are doing. So you'll have to, if you aren't familiar with what Acurast is doing, please look them up separately. It's some really cutting edge stuff that's happening with, actually edge phone compute. But what Christian is going to present today is how their confidential and distributed compute network can actually power the NANDA registry. So why don't you take it away, Christian?
Thank you so much for the warm intro. Yes, exactly. So I've been listening to all the talks, and to be honest, like lots of the challenges really sounded like what we were tackling for the last 3 years, such as being highly mobile, being privacy oriented, being safety critical up to trillions of devices. So it really sounds very aligned with NANDA. And that's why we also submitted to the RFP, of course. But let's dive right in. Don't worry, I'm not going to take longer than 4 minutes. So next slide,
Thank
please.
you.
So as you can see on this slide right here, we try to embed or sort of marry together the concepts that NANDA outlined, implemented in demos and also in papers, because we can offer compute, storage, and routing. So how can we embed it in this overall architecture and then also power the registry quilt, such as having a lean registry in the end or agent facts layer, and then sort of embed it and in all of this communication. Next slide, please. Why phones? So this is always important to outline why we actually do it. And as you can feel also during these 3 hours right now, it's such a natural choice, because if you want to tackle the centralized cloud providers, we sort of have to provide an alternative that is not built on traditional server hardware, because phones are decentralized by design. They're scalable by design because we have so many of them worldwide. Their hardware is really good. It can compete in terms of performance per watt. It can compete in terms of processing power. And then it's also verifiable by design because we have very secure chips in there that we can use to actually bootstrap a trusted execution environment, which then leads to the fourth point, which is that it's confidential by design. So this is sort of our backbone. We have 85,000 phones right now onboarded already. Next slide, please. On this flow here, we just wanted to exemplify how the Acurast processor, which in this case is a single phone that is locked down and only running the Acurast processor software, so it's also bootstrapping a trusted execution environment, how it is being used to process a query, for example. This is very simple. So it comes from the user, goes to the processor, and then also can return a result, of course. But this can also be embedded in much more complex interactions, of course. It can also run LLM inference, etc. So also depending on the science of the size of the model, this works pretty well. And then also for verification, sorry, just one more. For the verification, we can actually use it to verify, for example, agent facts. And everything is, of course, backed up by a chain that assures consensus. Next slide, please. So, of course, this implementation roadmap, I would redraft it after today's talks, but I think overall the outline is pretty clear. So we would have a standardized protocol to sort of enable interaction with different registries and also have a lean registry ourselves on Acurast, then do this as a pilot program and then use it also to optimize performance. So I think these three things are very clear and a natural match in my opinion. And then, of course, since it's research, it never ends, and it also never ends with regulatory compliance and growth at the end. And if this comes to fruition, we of course need to decentralize it in the end. So it's 9 seconds until 4 minutes. Thank you for the attention and have a nice day.
Thank you, Christian. You gave us 9 seconds back. So in this next talk, we're going to actually when we talk about AI agents and registries, and we're talking about why it's so important to have security, here's a whole critical sector where we're going to talk about space and talk about like a really critical sector where how is this going to work? And this is why we need to really think about interoperability, because we really don't want to just depend on one point of failure. So Sharath, why don't you take it away with 4 minutes on the clock starting now?
Hi, everyone. This is Sharat Chandra. I'm here to present my research and what I've discovered through looking through the ecosystem of space and the infrastructure for space. What I discovered in the last year of research in my quest to build a compliance solution for space and my obsessions for patterns. I discovered that, next slide, please. I discovered that space has the fundamental Byzantine consensus pattern. It covers multiple jurisdictions, both domestic and international. And in my observation, as Jessica mentioned before, I realized that frequency management is one of the major conflicting authorities across just the domestic agencies and not even international. What I'm proposing in this particular instance is, next slide, please, is that NANDA Quilt, the registry, the tools, seems like a perfect test bed to address the issue of infrastructure in space where satellites act as autonomous agents with DIDs, private registries. The regulators are nodes, and the option for the MCP architecture to discover other tools and forms across agencies. And what I'd like to do is to continue this research with Nanda and the team in order to find a perfect solution which could potentially allow for us to understand patterns within these regulations and contribute towards other regulated domains. Thank you.
Thank you, Shiraz. Well, this is something we're definitely going to have to figure out if we work when we go into the world, as we go into the world of a million, a billion, trillion agents, as that space will definitely have to be considered. So next we have Cameron from NEAR. I think we're all very familiar with NEAR's work. Cameron, why don't you give us an update on the work that you're doing? And in particular, I think for NEAR AI, it's very important as you are the platform for the future, future for Web3 AI. So what's the update on the latest that you've done? Do we have Cameron here? Oh, Cameron's not on screen. I think I'm going to ask you to rejoin as a panelist. I think you were kicked off.
Great. Hey, everybody. How's it
There
going?
you are. Hey, Cameron.
Good to see everybody.
Yay. I'm going to start the 4 minutes now.
Beautiful. So, hey, everybody. My name is Cameron Dennis. I've been building in this decentralized AI space for the last about year and a half. For those who don't know NEAR, it was started back in 2018 after one of the co-founders wrote "Attention is all you need." This is the Transformer paper, the T in ChatGPT, and built NEAR primarily to ensure that superintelligence does not fall in the hands of a single company. In order to do that, we first need to build a protocol that can actually maintain the scale needed to facilitate agentic commerce and AI. Second thing is we need to make sure that all of these different blockchains that exist can easily interact with each other, so users don't have to care what blockchain they're using. They just use apps that, well, fulfill the mission of user-owned AI. And then lastly, this sort of third important part is making sure that this whole decentralized AI stack, a tiny piece of it is laid out here, is an ecosystem. So it's we share a very similar goal with Nanda and sort of building this quilt. We recognize that there's no way that one company is going to be able to build all of this. This is many different companies, as you can kind of see here. And we're chipping away at this pretty quickly. And so when I had mentioned earlier that we don't have 5 years, we don't have 2 years, in our opinion. We have about 8 months to 16 months. And so in order to facilitate this, it first starts with all the compute. I don't know if everyone here should know, the new Blackwell series NVIDIA GPUs, H100s, H200s, and B100s will all have this trusted enclave in it, a TEE on the GPU, to facilitate verifiable AI hosting and training. And so we've been sort of at the cutting edge of this, not formally in collaboration with NVIDIA, but working closely to essentially drive demand for this new GPU TEE driver. And so we built something called the private ML SDK. Everyone's able to use it, totally open source, to facilitate private agent hosting. So we did this about a year ago. And since we last met, I think I gave a talk in about April, we've made a lot of progress. And so first off, we introduced this concept called shade agents. I don't know if you can see, I don't control the slides here, but okay, 2 more minutes. So shade agents are essentially agents that are verified on chain and have the option to be completely confidential. And so there's a slide somewhere else in this deck, if you're interested in looking at it later, unpacking that. You could also just go to shade agents on the NEAR AI docs and dive into that. The whole point here is you need to trust the agents that you're using. And the best way to do so is verifying the actual code that is running them on chain. And so we have a few amazing examples of this. They work in production today. Highly recommend looking that up. Second thing is we're enabled TEE agent hosting with Follow Network. Follow Network is a very close partner of ours that has been operating this TEE on the CPU side space for about 5 years. And so they have access to a lot of hardware and a lot of subject matter expertise to facilitate confidential and verifiable agent hosting. So that's a big part of the stack. If we're trying to ensure that AI is truly owned by the user, it needs to be verifiable. Next thing is, in order to get agents money, you're going to need to on-ramp fiat to crypto somehow. And so we're leveraging Coinbase's USDC on-ramp to on-ramp really any asset from any chain to any agent. And so there's an entire demo about that. Again, these are all separate companies that are building, and I work very closely with all of them to, again, sort of like, use the Nanda example, like build this quilt. And so we built that. It works. No KYC up to $500. It's pretty amazing. Next up is security. So if you want your agent to communicate with another agent, I want to make sure your agent isn't going to leak my private keys, or you're not going to disobey the privacy policies that it's interacting with. And so we do have an agent security framework built with a partner of ours called Vigil. And we're actually able to verify and test code even if it's confidential running inside of TEs. Got 10 seconds left, but TLDR implemented Google A2A cards, adding a huge liquidity, like adding a liquidity layer for all agents to transact. And most importantly, building an agent hosting network that is completely framework agnostic. And so doesn't matter if your agent's built on Crew AI or OpenAI or whatever, they will be able to communicate with each other. About,
Thank you, Cameron.
yeah, that's a lot. So hopefully didn't lose anyone.
No, I think your proposal is very similar in line with some of the other ones we've heard today, which is very holistic. And it's really great to see that you're thinking about payments and really holistically from the user perspective, which is, what you've all been doing. So thank you. Up next, we have Patrick Bois, that actually is the last presentation from the Artinet Project. And Patrick is going to explain how determined agent and identifiers can ensure this kind of synchronization that we're looking for across registries. So he provides a really good example of the kind of RFPs that we're looking for. And again, as a reminder, we have until June 30th. Today is just a peak. And now, Patrick, you're going to take it away with 4 minutes on the clock. Are
Awesome.
you ready?
Thank you.
There.
Yep, I'm right
I hear your
here.
voice.
Hey, how's it
Hello.
going, everybody? I'm Pat, and I'm a member of the Artinet Project. So we're a collective of researchers and engineers from around the world who are mission is essentially to democratize intelligence. Now, we built a platform and a set of tools that allows agents to connect, communicate, collaborate. And I'm going to walk you through how we synchronize registries on multiple indexes, multiple blockchains, as well as Web2 infrastructure. So next slide. So our primary goal with the Artinet project is essentially bring together fragmented solutions. So a fragmented ecosystem has essentially been created when it comes to agentic communication, and we're focused on creating a routing layer that allows messages to be sent back and forth from Web3 agents, Web2 agents, and all manner of agentic platforms. So next slide. So what are some of the core issues that the agentic communication is essentially facing? So some of them are barriers to discovery or limiting collaboration. A lack of standards is severely hampering the development of the ecosystem, as well as rapidly emerging protocols are creating fractured networks. And larger players are incentivized to create walled gardens, so essentially silos of agents that work really well within their own ecosystems, but maybe don't necessarily collaborate with other agentic systems as well. Okay, next slide. Okay, so in order to synchronize agents from across our kind of ecosystem, across our network, well, we determined pretty early on that deterministic agent identifiers would make that process a lot easier, as well as a lot kind of faster and easier to essentially link agents across networks, as well as their agentic details and agentic facts. So in the case of the Artinet, we came up with DAIS, which is a deterministic agent identifier. And this is composed of a core, essentially, registration that is consistent amongst most of these emerging agentic protocols. So like agent facts or agent cards and some of the other emerging communication protocols or listening protocols for agents. And we take those core details, we hash those, and then we hash them with a registry and identifier. And this identifier could be, a user's wallet or just a unique username, a unique ID related to the user's account. And we hash that again to create a DAIS. And this allows us to synchronize decentralized registries because of the fact that agent identifiers are deterministic. And that enables registries, clients from across the ecosystem to derive the same identifier for any given agent because of the fact that we're limiting the core fields of the registration to these aspects. Okay, next slide. Okay, so this is the last slide here. This is essentially the rationale for the goal of DAIS, and that's to ensure that registries and clients can derive the same identifier. Our constructions use SHA-256, which is highly available and efficient, and also has strong inbuilt collision resistance. The deterministic nature of these IDs make them easily replicable, make them easier to replicate across systems. Sorry, tongue-tied. It also facilitates deduplication and non-repudiation amongst agentic ecosystems. Initially, we intentionally decoupled identification from authentication to allow individual registries the opportunity to endorse agents without a central authority. DAIS are also naturally expandable, allowing them to become the root hash for composable namespacing or used as a standard and compliant method for generating DIDs. So decentralized IDs that the entire community can align to. And that's it. That's me for the Artinet
Thank you
project.
so
Thanks,
much,
everybody.
Patrick. This is a really great overview, and this is really cool that this is if someone can turn off their audio. I don't know who else we can hear your car sounds, but this is a really good. Someone just muted me. This is a really good idea, good take on. It's really cool to see, researchers coming together internationally to work on this in your collective. And so with that, I'm going to have Chris put up the last slide, which really gives an overview of the timeline for how you can participate in the RFP. Again, this is a really historical moment. I love that Jessica, former FCC chair, gave us kind of this history of situating us where we are historically. Is that we are in this kind of moment where these are like the early days of that's akin to when the internet was being built, or early, when the telephone numbering system, was started. We're in such a moment right now. And as Cameron also has mentioned several times, is that we don't have years, we have 8 months. From our perspective, we agree with that timeline. And this is why we started this industry association, is that we think that, we highly believe that collaboration is key. And as you can see from even the slight peak of responses within, just a week and a half, we got all these proposals, is that's very clear that not one company is going to offer this solution. It's going to require all of us to come together. And that's why we're going to post a link again for the July 15th event. It's for you to attend and also to participate in the community and to find ways to really contribute so that we can move much more quickly, so that we don't lose this window of time. And so I'm excited, and the rest of the team is excited to see more presentations. We'll be building out a steering committee who will be evaluating these solutions. And then on July 15th, we'll be selecting. You'll be getting a notice of presenters. You'll hear from some of the presenters that were here today, and we'll present again. But at that date will be key, because we're going to figure out how we're going to actually move forward to build the next step. And then on September 8th, we come together for the actual final presentation of a solution that we've come together as working groups. And even if you're not selected, we still want you to participate. So with that, I'll hand it over back to Chris. Thank you so much. And I'm going to post my information so that we can stay in touch and ask any questions.
Thanks very much, Tricia, and thanks to all the presenters. And just to reiterate, the on screen at the moment, that June 30th, that's the deadline you're working towards, Tricia, right? And I know
That's right.
we have an earlier date listed on the website, but we do need to change, but pay attention to this one. Good. And so we're going to move on quickly to, we've got a number of projects that have been working with NANDA, with A2A, with MCP, to help illustrate kind of how some of this is being taken into action, into the real world. We're all trying to build on this moving train, and these are a number of them. So we will start with Rob,